now moves on the next topic. It's very important topics in the examination point of view is colligative property. Colligative property is a property of the solution which depends only on number of the solute particle, does not depend on the nature of the solute particle. Write down the heading colligative property. Colligative colligative properties of colligative we will study the colligative properties in dilute solution containing non-volatile solute. Dilute solution containing a non-volatile solute. तो हम कॉलिगेटिव प्रॉपर्टीज डाइल्यूट सॉल्यूशन के लिए पढ़ेंगे, ऐसा डाइल्यूट सॉल्यूशन जो नॉन वोलेटाइल सॉल्यूट उसमें डिसॉल्व हो. ठीक है. हियर is the solid, or in another word this is called solid in liquid solution. Here solid is non-volatile solute, and liquid is volatile solvent. As we know that the volatile substance evaporate and forms the vapor and consequently form and create the vapor pressure. The non-volatile solute produce no vapor, hence constitute no vapor pressure. तो इस नॉन वोलेटाइल सॉल्यूट से तो हमें वेपर प्रेशर नहीं मिलेगा नहीं, तो इससे नो वेपर प्रेशर इज फॉर्म. A volatile solvent is only produce the vapor pressure. Okay. Now write down the dependence of colligative property. Colligative property colligative properties जिसको मैं शॉर्ट में CP लिखता हूँ. Colligative properties depends on number one, number of solute particles, number of solute particle. दूसरा, number of ions produced in solution. This is the number of molecules produced in solution. Fourth, molar concentration of solution. Molar concentration of solution. Molar concentration of solution. Okay. So now we can define the colligative property. Colligative property the property of the solution. Colligative property properties of solution depends only on number of solute particle, but not on nature of solute particles. For example, 10 ml solution of 10 ml solution of 0.1 molar 1.1 molar glucose and 10 ml solution of 0.1 molar urea both have same value, both have same values of colligative properties. Okay. The number of colligative properties, 4 important colligative properties. First is a relative lowering of vapor pressure, in short RLBP. Second, elevation in boiling point, in short EBP. Third, depression in freezing point, EFP. And the fourth and last, osmotic pressure, OP. So write down the first heading, the relative lowering of vapor pressure, relative lowering in vapor pressure, RLBP. RLBP, we have already learned that when a non-volatile solute is added to the solvent, vapor pressure of the solution decreases. इसके लिए हम दो क्लोज वेसल्स लेंगे. In first closed vessels we take in pure solvent. We have taken a pure solvent. These vessels contain a pure solvent. Pure solvent. Okay. Another vessels containing a solution of this solvent. Solution, non-volatile solute dissolve in the solvent and form the solution. This container contain solvent as well as solute, non-volatile solute, like this, called solution. The vapor pressure of the pure solvent is denoted by P naught. A solvent is denoted by subscript A, and vapor pressure of the solution represented by P PS. Okay, so vapor pressure of the solution decreases. Vapor pressure of the pure solvent is high than the vapor pressure of the solution. But how? If we look a pure solvent, there is the only a solvent molecule at the surface of at the surface at the surface of the liquid. Pressure of the solution represented by PS. So here, the vapor pressure of the pure solvent, in case of solvent, the entire surface is occupied by the volatile solvent molecule. Therefore, the more number of molecules evaporated and forms the vapor. But case in solution containing a non-volatile solute, some non-volatile solute is also occupied surface, which contribute the no vapor pressure. Therefore, the vapor pressure of the solution decreases. Here only the few vapors form. So this is clear from both these both these diagram, that the vapor pressure of the solution is lower than the vapor pressure of the pure solvent, and the vapor pressure of the solution is only due to the vapor pressure of the pure solvent. Okay, so this is always important to note that vapor pressure vapor pressure of the pure solvent is always vapor pressure of pure solvent is always is always greater than its solution, always greater than its solution. Okay, if we calculate the difference between the vapor pressure of the solution and the solvent, we get lowering in vapor pressure. So for the difference, higher minus lower, So higher vapor pressure is pure solvent vapor pressure, P naught A minus vapor pressure of the solution. This difference between the vapor pressure of the pure solvent and the solution is called lowering in vapor pressure. If this lowering in vapor pressure is divided by pure solvent vapor pressure is called relative lowering in vapor pressure RLBP. Relative lowering in vapor pressure is a colligative property, but lowering in vapor pressure is not a colligative property. इसको ध्यान रखें कि lowering in vapor pressure is not a colligative property. A relative lowering in vapor pressure is the colligative property. Okay, a relative lowering of vapor pressure is equal to relative lowering of vapor pressure is equal to P naught A minus P solution upon P naught A. This is whole called relative lowering in vapor pressure is equal to mole fraction of solute, which is represented as XP. So we can write the relative lowering on vapor pressure as P naught A is equal to mole fraction of the solute, or I is the bent off factor. Okay, so I is I into mole fraction of solute is equal to moles of solute upon total moles, or moles of solute upon moles of solvent A plus moles of solute B. Okay, or for a dilute solution, because we deals only a dilute solution in the colligative property, the band of factor into moles of solute upon moles of solvent. This is important formula chain for the relative lowering of vapor pressure. The relative lowering of vapor pressure P naught A is equal to band of factor moles of solute upon moles of solution. For this is for dilute solution. Dilute solution where the moles of A much greater than the moles of B. So here what we have done, we neglected the moles of solute, because the moles of solute is very less. For the dilute solution we will apply this formula. Okay, this is all about the relative lowering in vapor pressure. In the next colligative property is elevation in